Sounds good. Thanks, Leah. Hi, my name is Mike Dorfman, and I'm working with the National Snow and Ice Data Center to compare two sets of data that describe sea ice around Antarctica. These two data sets describe the marginal ice zone, which is typically defined as sea ice that covers between 10% and 80% of the water's surface. Sea ice concentration, which I'll refer to a number of times later in the presentation, is the percentage of ice covering the water's surface. The comparisons I've made in this project focus on the differences between these two products and quantifies these differences. I'm not indicating one product is more accurate than the other, I'm just investigating and quantifying the differences. The ice surrounding Antarctica is critical to understand for several reasons. It teems with sea life sheltering the broken ice, it drives distinct weather patterns, and it impacts crucial trade routes for ships. It's also essential to study the changing state and annual cycles of sea ice as ice caps shrink in a warming climate. There are a handful of differences between these two products, but a couple of important highlights from these differences. The CDR dataset is a continuous measure of sea ice concentration from 20% to 100%, whereas the NIC dataset buckets the data into two categories, 10% to 80% and greater than 80% sea ice concentration. Also, the two products define the outer extent of the marginal ice zone at different sea ice concentrations, 20% for CDR and 10% for NIC. So my question is, how do these two data sets compare? I guess that the NIC marginal ice zone would extend farther out to sea than the CDR marginal ice zone for a couple of reasons. The outer extent of the MIZ in both data sets does not necessarily line up since the sea ice concentrations are different. Additionally, microwave models typically underestimate sea ice concentration, pulling the CDR MIZ further south as well. In my approach to analyzing this data, after pre-processing, I found the difference in total area of ice within the outer perimeter of the marginal ice zone, as well as the difference in total area of ice within the inner perimeter of the marginal ice zone, and plotted the resulting data. In order to better visualize the differences in these two products, I've created plots that represent the inner boundary of the MIZ for each month of the year. You can see the blue line here representing the CDR dataset is farther south than the pink line representing the NIC dataset. And this is a similar plot, except during the springtime melting of the sea ice. You can see there is a much greater difference between the two products during the melting season. In order to quantify how much less the NIC MIZ extent is compared to the CDR, I've graphed the total areas of sea ice concentration for both products. The areas plotted here show the NIC MIZ extent in the pink area and the CDR extent in the blue area. You can see both the outer and inner extents of the MIZ are further south in the CDR product compared to the NIC product. The lines plotted on the right axis show that while the NIC's MIZ extent is farther out to sea than the CDR, the total area of the MIZ is actually larger. Let's dive deeper and quantify how different the two products are. What type of adjustments could be made to the CDR product to make it look like the NIC product? In other words, for the line representing the inside of the MIZ in the CDR product, the bottom of the blue area here, where does that have to move to match up with the inside line of the NIC product, the bottom of the pink area? I've updated the graph with different inner MIZ boundaries for the CDR product. Each line here represents a 5% increase in sea ice concentration. The lines at the top roughly match the sea ice concentration at the bottom of the NIC data. I also took a more numerical approach to lining these two data sets up and found that the CDR product typically reports about 30% sea ice concentration when the NIC product is reporting 80% sea ice concentration. Ignoring the outer threshold of the marginal ice zone here, you can see the bottom of these adjusted graphs do roughly line up, where the NIC is at 80% and the CDR is at 30%. I've animated the median plots from earlier in the presentation on this slide, and on the following slide, you'll see the same plots except with the CDR product set to 30% sea ice concentration instead of 80%. You can see the sea ice concentration boundaries line up much more closely in the first animation than the second. For the next steps, I've already run the same comparison on the Northern Hemisphere, and it'll be helpful to do more research to get a better sense of why we might be seeing these differences. And I just want to thank Jenny and Leah for their help, as well as Florence Federer at the National Snow and Ice Data Center for assisting me throughout the analysis and helping to answer all my questions. Thank you very much.